All right, let's start. Good morning, everyone. So today we're going to talk about Agentic AI and the role of MCP. So just out of curiosity, who is using MCP in their organization already? All right, so 4. And who wants to use agents, maybe in the future? Okay, that's almost everyone. So very good. So everyone is on this road towards becoming an agentic enterprise, and MCP is one small stepping stone to get there, and we will talk about this today. What I hear when I talk to enterprises is that the top level management basically has on their agenda that they want to become this agentic enterprise. They want to have AI agents all throughout their organization, right? To unlock productivity, to become more efficient. So 61% in one of those studies say of CEOs that they are actively adopting AI agents in their organization. Now, there's a lot of numbers that back that up. But here is one very interesting number that's, that CEOs know that their organization is actually not ready to transform as fast as it has to transform. So they actually need to push people to adopt AI much quicker. But what is it actually as a vision that these CEOs have when they talk about agentic AI? So they think that in every department of the company, so here I've just symbolized this with HR, sales and marketing, R&D, and IT, you will have new colleagues, and those colleagues will be AI agents. And they sit right next to every one of your colleagues that you already have. The idea is to get more done with the existing workforce so that the people can basically offload some simple tasks to the agents, and then they can focus on some more complex tasks. That's the idea of the agentic enterprise. All right, but then there is, of course, a little problem with that vision. It's not reality yet. What we see is the challenge actually shows itself by this gap of what people think they want to have and what's actually possible right now. People are building AI prototypes. That's what I see right now. So when they talk about we're on the road to building an agentic enterprise, then it's mostly AI prototypes. So it's internal use cases that no customer is ever going to see, or it's really just prototypes. And then there is this big gap, this big Grand Canyon in between those AI prototypes, and on the other side there's the mainstream adoption of agentic technology. So that would mean that I am ready to have business-critical processes running on agentic AI and something that's customer-facing, right? So that would be the next level step. And companies are not ready to cross this gap. They are stuck on the left side in this AI prototype land, and they can produce impressive things there, but they don't dare to go into this business-critical customer-facing use cases. So why is that? Any ideas? Why do you think companies don't want to cross this gap if they have prototypes that are working? Cost could be one of the things. Running those models is very, very costly at scale, absolutely. But there are companies with deep pockets, right? So they would be able to do that. Yeah?
I think it's very risky to hand over tasks to an AI now.
Yeah, so you have this very interesting word you said, risky. So risky. What does this mean? It means there is a trust issue, right? There's a risk that those AI agents don't do what we want them to do, that they go off on their own and do things we don't really anticipate. Yeah?
Isn't there something more like abstract as well, because an AI agent is not responsible in the same sense that human beings are, and if a manager is managing 10 AI bots instead of 10 humans.
Who's responsible?
Yeah.
And
the productivity is much higher, whereas the accountability is zero.
Exactly, exactly. So I think this could also be mapped to a trust issue, right? So it's like we don't trust them, and because we don't know who is responsible in the end. So what I think here is also underlined by lots and lots of studies. You can see them small print there in the bottom. There is, for example, a study by MIT, State of AI in Business. That's from last year, I think. And they basically say 95% of all AI initiatives fail. And this is also backed up by studies by McKinsey, by Gartner. So they all come to the same conclusions, basically. There are technical reasons and there are trust reasons why this doesn't work. So, for example, here, Gartner says 85% of AI projects fail due to poor data quality. Okay, and then 70% from McKinsey, AI projects fail due to data quality and bad integration, right? And then Forrester Research says 68% due to quality and integration challenges. And so there's some problem in the integration infrastructure, apparently, and there are some trust issues. What's not going to solve this? What's not going to solve this problem? What I sometimes think people are waiting for is like the next best model version. That's not going to solve the problem, right? If we wait for the next model that's even better, that's not going to help us bridge this gap. But what is then? How can we create trust? So what I argue in this talk is that we need to have a platform, a trusted platform, that helps us build agentic AI to access enterprise data. So if we have this trusted foundation in the bottom, we can build agents on top, and then we can trust those agents to also get them into production in the long run. But of course, the question is, what elements would such a platform need to have? What is in this platform? Now, very abstractly, I think there are three things in this platform. The first one is we need to be able to write agentic AI in a very efficient manner. So there needs to be a framework, so we don't have to write the same code over and over again. Right? So some form of framework we need. And that's quite obvious, and that's why I put this in the box on the outside, right? Agentic AI. A little bit deeper, and some people don't see this, also backed up by the research I showed you before, is that integration and interfaces are super, super important from a technical perspective to realize those agents. Not everyone understands this, right? And I'm going to show you why that's so important. So provide access to heterogeneous enterprise data to AI agents. AI agents don't want to work with generic knowledge that's in a model, that's in a pre-trained model that some of those big AI companies have created. They need to connect into the enterprise data. Real-time data, data about your customers, data about your products that only you have, that's not in the model, but that can be added to the model via an interface, via integration. And the third thing, and that's very important for creating trust, is governance. So you're creating some rules, constraints, and guardrails around what these agents can do. And it's not only on the top level what the agent can do, but you look into every component of the agent that the agent is built of, and you kind of build a box around it. Okay. There are different types of governance. There is the endpoint governance. That's something we're here at the API community, that the API community is very familiar with, right? So we are the experts at endpoint governance. And this knowledge is now very, very important when we want to build agents, because all these different components of agents are stitched together via interfaces. Those are the control points for the agents to build trust. So we leverage this. Our community, the API community, is in a prime position to build trust in agents. And then there is, of course, model governance. So the governance of the model itself, so the model creates politically correct answers and doesn't run off in strange directions. That's another form of governance that we need to look at. Okay. And the talk is structured like this, that now I'm going to deep dive into each of these three different topics. Right? We're going to see what is actually behind it. So first one was Agentic AI, building AI agents. Now the big question is, what is such an AI agent in the first place? Most people say, okay, yeah, we know the AI agent is built with an LLM or with some AI model. So how does an LLM work? An LLM works like this. You have some input, a prompt given to the LLM, and out comes a response. So if I say, for example, the quick brown fox jumps over the lazy dog. Exactly. So you are a good LLM, because what the LLM does is completion of a sentence, right? So what we just did, I did the prompt, and you did the completion of the LLM. Thank you very much. There is, when we want to build agents, however, a problem with a pure, naked LLM solution. And the problem is that there are limitations. So this LLM is kind of locked in. And it's locked in because it's limited to the data that has been trained on. It cannot reach out to any enterprise data. It's just at the time it was created, this data is in there, and it doesn't know anything else. So how do we fix this? The next iteration is then this RAG, Retrieval Augmented Generation, where you say, okay, I have some input as before, but now I don't give it to the LLM directly. I first try to expand the context in my local environment. I have a local vector database with a semantic search capability. So I search out basically out of a knowledge base that I have locally, some snippet of information that's relevant for the prompt. And then I add this to the prompt before I send it to the LLM. And then the LLM is going to produce the output. Okay? So that's the next iteration, how I can leverage LLMs. There's also a limitation in this approach. See that already? What do you say? Cost? Yeah, absolutely. Cost in all LLM, and especially here, because with RAG you have such a big input, like a context, that's so big, too many tokens in there. But there's also like fundamentally a problem that you don't have any real-time data in there. It's just in this database that's static, right? And you can't act on the data. You would like to do something with the data, not just produce some text. So what we actually want to have is more. We want to have an LLM that can work with the environment. It can get real-time data out of its environment, and it can act in this environment. Okay? Perform some actions. And that's what agents actually do. They can perform actions, and they can deal with real-time data out of the enterprise. All right. So there's a couple of patterns used by agents. So of course they have the LLM, we know that. But how do you use the LLM? When you write an essay on a specific topic, do you write it start to finish in one go? Who does that usually? No one? Yeah, I can't do that either. I write something, delete it, then I write the third sentence before the second and stuff, and then I need to rearrange it. So it's not linear. But what we expect if we use an LLM with a one-shot or zero-shot approach is that it writes it start to finish and it's perfect. Right? That's how we usually work with LLMs. Agents don't work like this. They work more like humans. They say, if I want to work on an answer, I don't do start to finish in one go, but I do it iteratively. I use the LLM multiple times. So first, I use the LLM just to do some research, get some research. Then I use the LLM to plan out how my essay is going to look like outlines and so forth. Then I write a draft. Then I use the LLM to critique my draft. Then I use the LLM to revise my draft. Right? So it's iteration. So that's one very important design patterns that agents are using. There's more design patterns. Iteration is at the heart. There are, I put 4 more up here. Let's look what they are. The first one is reflection. So the ability to examine your own work, to critique it, improvise it, and revise it. The second one is tool usage. So basically, I need to get real-time data knowledge. These are tools. The third one is some form of planning, and the fourth one is collaboration with other agents. So each agent is a specialized worker, and then multiple specialized workers together can create a complex solution or a solution to a complex task. All right, so how does this reflection work? Here's an example, right? So the first iteration with the LLM could be that I prompt the LLM to say, generate some code to classify objects in an image. And the LLM is going to produce some code. Now reflection works like this, that I take the output that the LLM has generated and I put it back in to the input. And I say, here is some code, put that code in, check the code and provide constructive feedback. Right? So you loop over it, you get some feedback, and the third step is here's some code, here's some feedback, put that together and provide an improved version. Okay. So that's reflection, kind of the idea of reflection, how agents can leverage this. Then the idea of tool usage. I mean, that's clear. Tool usage is APIs. You have some data, some functionality behind an API, for example, for searching, for getting real-time data, for getting enterprise data, and you stitch it into the interaction with the LLM. So I'm not going to go through all of these. Yes. So tool usage, I think, is super, super important, because if we think back on how we as humans have developed and how our civilization has developed, there was like a very important inflection point, and that was when we started to use tools as humans. Very many millions of years ago, we started to use tools, and we became much more capable and powerful. And now with those tools, APIs in the context of an LLM, the LLM or the agent becomes much, much more powerful. Right? So it's, I think, a very similar inflection point as we've seen previously. Planning, I'm not going to go over this in too much detail, so you can have a plan for, and then work through this plan step by step. What's very interesting right now is agent collaboration. So if you have a complex task, you have multiple agents that are specialists. So here in this example that they have visualized here, you have an organization that creates software, and then you have people in testing and documentation and product management. And these are basically just agents that interoperate. Yeah. So with this, I've shown you a couple of patterns for realizing AI agents: reflection, tool usage, iteration, planning, and agent collaboration. All right. I would say what people are using right now are the top ones: reflection, tool usage, maybe a little bit of planning. Agent collaboration is something that people think about, but I don't see it in use so much yet. To summarize what we've seen, reference architectures for leveraging LLMs. In the beginning, we had LLMs and prompt engineering. Does anyone remember in the beginning of LLMs, like in 2023, people said on LinkedIn, okay, there's going to be new jobs and it's going to be prompt engineering. It's going to be the new jobs. It didn't go away. It's still relevant today, but it's nowhere close to as important as we thought back then. The next reference architecture over time that we've developed is retrieval augmented generation. You can still combine this with newer reference architectures. Didn't go away. It's just not the end of the development. And then now we use AI agents. So you get much more value out of the AI with these AI agents. And AI agents basically leverage RAG and prompt engineering and LLMs. Now, from an architectural perspective, what are AI agents? AI agents have three components. They want to be intelligent and autonomous. Then they want to be able to use enterprise data. They want to be skillful. They want to use tools. And the third thing is they want to collaborate. So I can put all of these things up here. So these characteristics, intelligence, ability to act and get knowledge that's relevant, and collaboration. That's very abstract. How do we realize this? Like if we build an agent, actually. For intelligence, how do we do that? Exactly, with an AI model or mostly with an LLM. For contextual knowledge and ability to act, that's actually our APIs, right? That's our API that we already built. But in general, it's just access to enterprise data, functionality. There's new protocols that can be used here. But the important thing is getting to those very specific enterprise data that you only have. And then collaboration is collaboration with other agents. Also new types of protocols here. And of course, you need to collaborate to find the right agent for the task. You need to give the task somehow to another agent that's a specialist in a subtask maybe, transfer the context, hand it off, and integrate the results afterwards. So that's what agents in an agentic enterprise need to work with. Now, coming back to the big idea with the trusted platform. So what we've talked about is the outside, the agentic AI. Now, the next thing would be looking a little bit deeper into this platform, and that's all about integration and interfaces. So what's the role of integration and interfaces? It is especially important when we want to have access to enterprise data. So how does an AI agent connect to enterprise data? There is actually lots of ways of how this could be done, right? So people have looked at direct API integrations, AI frameworks. I mean, there's a whole bunch of things. The problem is, however, if you do any of these approaches and you want to exchange any of the components in your AI agent, for example, you want to swap out an LLM, it's not going to work. You will have to rebuild your stack completely. And that's because there's no standardization in how we connect an LLM to our enterprise systems. There is, however, right, if we use the standard, the MCP standard, Model Context Protocol, then multiple LLMs will support this, multiple frameworks will support this standard, so we can easily switch out things without having to rewrite how we integrate with our enterprise application. So that's basically the best practice, how to use enterprise data in an AI agent. All right, I'm not going to go over details. It's a client and a server. Yeah, that's okay. Okay, so you use MCP as an interface to reach into your heterogeneous landscape that most enterprises have, which consists of on-prem applications, SaaS applications, maybe some old mainframe applications. And you would need to reach out into each and every one of those. To do that efficiently, most people use an integration system or an integration platform that has kind of the reach into all these different parts of your system. So what I see usually is that you have an integration platform, and that exposes an MCP endpoint, which is then used by an AI agent. All right. But if we look at other interfaces that we need, so it's not only the tools in the middle that we need for AI agents, but we also have AI models and we have other AI agents, left and right. How do we connect to those? There's also interfaces involved. So here I just added the interfaces. So if we have the AI agent reaching out to AI models, that usually uses LLM APIs, some form of REST API. What we've looked at reaching out to enterprise applications is done via MCP, and reaching out to other AI agents is done via the A2A, the agent-to-agent protocol. If you look at these different types of interfaces, you can kind of classify those interfaces. So some of them are basically going in a vertical direction. So the MCP and LLMs, those are components that are kind of going down into the system architecture, deeper into the system architecture, and then A2A is more on a horizontal level, an agent collaborating with another agent on the same, like peers working together. So if I put all of this into one diagram, what we've developed, then it would look like this. I have the AI agent, which has 3 components, and these 3 components are exposed via interfaces, different types of interfaces, like so APIs, MCP, A2A protocol, and especially for the middle part, for MCP, we need to have integration technology. All right. Going back to our overarching picture here on the trusted platform for agentic AI. We've looked at agentic AI, we've looked at integration, now we come to governance. All right. And that's the most hidden. Most people don't think too much about governance. They want to build an AI prototype quickly. And you can build prototypes quickly without having governance in place. But you might not trust those agents to bring them into production. So why do we need governance? Why do we need API governance? Yes, so it's exactly, it's a security issue also, right? To access those critical systems, right? We don't want, for example, that these hackers come in, and now these hackers can not only be like persons, but it can also be agents, and it can be agents that maybe are not just not functioning correctly. Maybe they're not even malicious, but they just don't function correctly, and they hammer our systems and have basically creating denial of service attacks. Okay, so how do we do this governance? This is the picture we have started with. So governance can be created, especially endpoint governance, at exactly those interface points. Okay. So wherever there was an interface, we just put a gateway now. And a gateway helps us to control what goes in, what goes out. We can put some control in who has access, who doesn't, authentication, authorization. We can control the cost. I think that came up before here in the audience, that people are concerned about cost. So governance can help you control the cost, especially on this side. Right? So if you want to access your LLMs and AI models, that's where usually the cost comes from. So with an AI gateway in between, you can say, maybe this AI agent has already used up the max allowed number of tokens for this day, and we just close it. Yeah. Okay. So what we can see on this picture as well is that we have different forms of governance. So I think this one here, right? We can have governance via the gateways that's what we do in API management as well. We have the same concept with API gateways. So we govern the components of the AI agent over here. So for each of the 3 components, we have now a governance possibility. We can also govern the AI agent overall. And especially here in this area, we can also govern the models. So we can see that the models don't produce any strange kind of results. So that would be a different type of governance that we put on those AI models. Good. Architecturally, I have mentioned a couple of times, hey, this is all so similar to how you've built your API architecture and how you have your API gateway and your enterprise architecture. So I thought I'm going to develop a little bit, how does your enterprise architecture change when you now have agents with those 3 different gateway components? Okay, so this should be an enterprise architecture that people from the API community maybe are familiar with. So what you see here is an experience layer on top with a mobile application, a web application, and then you have your integration layer. Maybe there is an integration platform and a gateway in front of it. And then you have your operational systems underneath. And they sit everywhere where they just sit on a mainframe, SaaS applications, on-prem applications. Does that look familiar? Who has a similar architecture in there? Almost everyone. Right. So how does your architecture need to change now when you have agents? How do you evolve that? So I have put the API-based architecture now just to the side, so it's still there. And I've introduced a new layer called the agent layer. It's right in between the experience layer and the integration layer. And there are 2 agents in there. Of course, in a real setting, there would be many, many more agents. But one agent has an interface, a conversational interface that I can chat with. And the other agent is more reactive, like sitting in the background and waiting for some system event to trigger it into action. Okay? And then under the agents, there are our 3 components that we have seen. So there's the LLM gateway, the MCP gateway, and the A2A gateway sits right next to the API gateway. The A2A gateway connects an agent to another agent. The MCP gateway via the integration platform connects into our existing operational system landscape. And the LLM gateway protects access to the expensive AI models. Okay. Yeah, and then sometimes people ask me, yeah, how does such an MCP gateway look like? And I'm now just zooming in to this MCP gateway and look inside the box. So let's see, what do we have here? On top is the agent. On top is the agent, and in the bottom is our backends. And then in between, this is the gateway, right? So there's, just like with an API gateway, there's an MCP, now an MCP proxy, where the request comes in. Then you have maybe a protocol conversion to some of these protocols, API or REST, that's connected in the backend. And then you route to the backend, and you apply a lot of these policy logic, constraints or policies. Authentication can be done, you can limit the quota, you can protect from denial of service, all of these policies that you're already familiar with from your API gateway. And that's how you can create governance on, for example, on MCP. All right, how we do time-wise. Best practices. Now, we've looked at some slides about AI agents, and it looks all very nice, like this castle here. And even if we then zoom in and we look at the A2A protocol and MCP, it's like these nice gardens, looks really nice on PowerPoint. But what we need to do in the end is we need to connect these MCP endpoints to the data that we have. And there is a lot more mess in this data that we have, and we have a problem like API sprawl, which is not going away, right? We'll still carry this problem with us into the agentic world. So we'll need to fix that problem, no matter what. All right. So a couple of best practices for MCP and API governance. So managing sprawl, just apply best practices that you may be already familiar with for API management, right? Use your open API specification style guide, automated linting, maybe a common terminology. And then you have not only the sprawl of your APIs and your MCP endpoints, but you now have sprawl of different gateways, right? Because we've seen an agent needs 3 gateways on top of the API gateway. So there is also this idea of federating all these API gateways together. Designing APIs for MCP and for agents is still very, very important. So intentional API design is even more important for agents, I would say, because agents need to have, they're kind of picky on their APIs. They don't want to have these low-level system APIs because they would have to break down the complex task that they need to do so much that to get down to these system APIs and all these different system APIs that are so fine granular. They can't do that, or they mess up somewhere in this process. So what you need to do is you need to lift up the level of your APIs, have more business and intent-driven APIs, so that the LLM doesn't need to work so hard to find the right data points, right? So it finds it quickly. And then, of course, you need to still focus on security. When I see people work on AI prototypes, they just skip all of the security stuff, right? Because they are so excited about bringing out the new capability of this AI prototype. But if you want to bring your agent to production, then you just can't skip it. So it's even more important than it was before. Then using different tools in agents, you can't just put your complete API landscape into an agent and say, use whatever you want. If you have thousands of tools and APIs in your agent, it will be overloaded basically, and will be too expensive to do that. So you have to kind of select which tools are the right ones to use. So limit it to 5 to 15 tools. Don't have overlapping tools in your agents. Some of the best practices here. All right. Now we have this new protocol. We have MCP right next to APIs. Most people already have existing API landscapes. So how do we deal with new APIs that should be developed? Should we build now MCP endpoints, or shall we build still APIs? And what do we do with our investments in APIs? Do we automatically transform every one of these APIs into MCP endpoints so they can be leveraged by agents? What are some best practices around this? Okay. So what most people see is this stack. There are the systems, then we have APIs that take the system data in API form, make it available, and then we have an MCP server sitting on top of the APIs, giving it to an agent. And the big question is, well, there's this API and MCP, which one shall we pick? Do we need both of them? Just one? And I would say, I would rephrase the question. I would say, excuse me, our APIs are not all the same. Yeah. So some APIs are more system APIs. So system APIs just expose the data and the functionality that's in our systems one-on-one and bring it into the API world. Then we have process APIs. Process APIs are specific for our enterprise. They are kind of an orchestration or an integration of several of these system APIs into a process that's relevant for our organization. So there is some business value or business logic kind of encapsulated in this process API. And then we have experience APIs on top. Why do we have this? What is an experience API? Experience API is very similar in concept to a process API. It's a variant of a process API. So I filter out certain fields of the process API because I adapt my experience API, or I orient my design of the experience API to my users, to my clients of the API. So I have different small variants. And now I might have one variant that's especially suitable for MCP consumption. And here I can do an automatic conversion from an experience API into an MCP server. But I wouldn't do this on a plain vanilla process API, and I wouldn't do it on a system API. So if I have the right experience API in place, I can automatically transform one protocol into another protocol. All right, so this I have explained. All right, one more concept. We had API sprawl, and now we have gateway sprawl. So over time, we have accumulated so many gateways in our organization. Especially large organizations have a lot of different API gateways from different vendors even in their organization. Now with the advent of AI and AI agents, we have different AI-related gateways. And so this just adds to the amount of gateways that we have to manage. Let's look into that, how it looks like in an organization. So this is our architecture here. In the bottom we have our backends. Here's our gateway landscape. On the top are our agents and our applications. Right? So in the application area where we had APIs, we might have an API gateway that is on-premise. We might have an API gateway that's in the cloud. We might have an API gateway of vendor A and an API gateway of vendor B. Now we have for agents an MCP gateway that brings our existing backends into and APIs into the world of MCP, make it available as tools for agents. Then we have the LLM gateway, which kind of blocks traffic or manages the traffic for cost control mostly of the agent. So the agent reaches out not directly to the LLM, but via the LLM gateway. So we have a control point here and can open this up or close it, however we think is useful. And then we have an A-to-A gateway. So the agent talks not directly to another agent, but via this A-to-A gateway. So bringing all of these gateways under one roof can be a thing that we want to think about. And we have already concepts, and these concepts come from the API world. So we have these federated API gateways, and I think we should evolve this into a federation of not only API, but also API and AI gateways, and bringing all these different concepts together in one control plane where we can manage them properly. All right. So to summarize what we've seen, to realize the agentic enterprise, we need to build trust. And we do this by having this framework here, a platform that provides trust, a platform that allows us to build AI agents efficiently, a platform that allows us to have all these different forms of interfaces and integration, and a platform that allows us to realize governance. Model governance and endpoint governance. So thank you very much for your attention and for working with me. Hope you have a good day at the conference.